The Anthropic Spring 2026 release cycle introduces a specific technical capability, a single, continuous path that carries a conceptual sketch through to verified code. This replaces the traditional friction of manual handoffs between model APIs, standalone coding agents, and external design tools. The system operates across three interconnected layers: the Claude Design visual interface, the Claude Code 2.x terminal, and the Opus 4.7 compute engine. These releases establish Anthropic as a product-focused organization, delivering specialized tools that surround the underlying research models. Automation at this scale faces a steep reliability gap. There is a significant difference between a prototype that looks correct and code that is ready for a production environment. Bridging that gap requires hard system constraints and closed-loop tooling. Increasing model parameter counts alone does not solve the problem of autonomous execution. Successfully deploying AI in 2026 requires moving beyond simple prompting to coordinate this entire orchestration system. This workflow begins in the visual conceptualization phase within Claude Design. Anthropic built this as a 0 to 1 layer for non-designers, such as engineers and product managers, rather than a direct replacement for high-fidelity tools like Figma. The technical foundation of the tool is a feature called Design System Import. Claude reads an organization's existing codebase and JSON design files to learn its specific colors, typography, and established governance rules. These learned constraints are applied to every text-to-prototype generation, preventing the model from introducing off-brand hallucinations. Users can provide a PDF product spec or a rough sketch, which the model converts into an interactive visual canvas. For further refinement, the system hands the project to Canva for multiplayer collaborative editing. Anthropic is transparent about the tool's limits. If the source codebase is unorganized, the resulting design output will follow that same pattern. By forcing generative AI to operate within pre-existing organizational rules, the tool removes the initial friction of starting from a blank page. Once the visual design is set, the task moves into the implementation layer, the Claude Code 2.x terminal environment. Claude Code 2.x functions as an agentic orchestration environment, managing the lower-level terminal operations required to build the software. Most autonomous agents require constant babysitting, stalling on permission prompts or failing to execute model context protocol tool calls correctly. The specific solution to this friction is the \less permission prompt skill. It scans session transcripts for common read-only bash and MCP calls, then proposes a prioritized allow list for the local settings file. For Mac subscribers, the new Auto mode allows Claude to handle longer tasks and make logic decisions with fewer interruptions. To ensure reliability, the /ultra review function provides a final quality control layer. This function acts as a senior reviewer, targeting logic gaps and design flaws rather than simple syntax errors. These tools change the developer's role from a terminal micromanager into a high-level systems orchestrator. This table highlights the foundational compute layer, the Claude Opus 4.7 Mythos class model, featuring a 1 million token context window at standard pricing. Large context windows allow for complex work, but unconstrained agentic loops create a significant risk of surprise API costs. To manage this risk, Opus 4.7 introduces an economic constraint called task budgets. Developers can set a hard token limit for a full agentic loop, including the internal thinking process, tool calls, and final output. The Opus 4.7 agent monitors this countdown and prioritizes its remaining steps to finish pragmatically before the budget is exhausted. Anthropic recommends the X-high effort tier for this work, as it offers a balance of reasoning quality and lower token latency. Upgrading to Opus 4.7 also requires attention to a shift in token accounting. A new tokenizer maps the same input to roughly 1.0 to 1.35 times the previous token count, requiring developers to adjust their max token headroom. True autonomy is only viable in a production environment when it is bound by these economic and computational constraints. Integrating these three layers results in a fully realized end-to-end execution loop. The process begins with a product specification in Claude Design, where organizational brand guidelines are automatically enforced. That visual prototype is then handed to Claude Code 2.x for autonomous implementation in the terminal. Throughout the process, Opus 4.7 manages the execution within strict token budgets and self-verification cycles, Complex tasks, such as code-based migrations or refactors, can now be bounded and executed without leaving the platform. This shift changes the core engineering problem from babysitting individual prompts to coordinating multiple agents in parallel. Assessing the current state of AI requires looking past raw model benchmarks to evaluate the efficiency of the entire orchestration stack.